Hello, in this last video we are going to continue lesson 7.3 by using systems to solve word problems, and we might be using the substitution method, or we might use elimination with addition or subtraction, or we might use elimination with multiplication. It'll just depend on what our equations look like. So like with all of our word problems, we have our directions here: define our variables, write a system, solve it using one of the three methods we have learned in this unit, unless you really want a graph, and write your answer in the complete sentence. So here we have a working one. We have that Tammy works 2 jobs. As a clerk, she earns $7 an hour, and as a receptionist, she makes $9 an hour. 1 week, she worked 24 hours and made $200. How many hours did Tammy work at each job that week? So what is it asking for? It's asking for how many hours she worked at each job. So our variables are going to stand for the number of hours she worked at each job. So let's say X equals the number of clerk hours. That was the first job they talked about, clerk hours. And we'll say that Y equals the number of receptionist hours. Receptionist hours. Okay, now we're going to use those variables and the other information to make 2 equations. As a clerk, she earns $7 an hour, and then as a receptionist, she makes $9 an hour, and that week she made a total of $200. So again, we're going to put all of our money numbers into one equation. So that would be 7x, $7 times each clerk hour, plus 9y, $9 times each receptionist hour, and that equals $200 that she made. The other number we haven't used yet is the 24, and that was the total number of hours that she worked that week. So that's just x plus y equals 24. All right, so now we have our system. Let's decide what method. It doesn't say like x equals or y equals anything. That wouldn't be too difficult to do. Like you could take the bottom equation and solve it for x or y. So you could technically use substitution. The coefficients aren't the same on either one of the variables, so we can't right away add or subtract the equations together, but we can multiply the bottom equation so that you can get the coefficients to be the same. Let's do that, and let's get the x's to be the same. So, and I just chose that. I mean, there wasn't really a reason. You could get the y's to be the same if you would like. But if I get the x's to be the same, then that means I need this bottom equation, I need it to be a 7. And it would be really nice if it was also the opposite. It'd be really nice if it was -7. So I'm going to multiply the bottom equation by -7, and that'll give me a new system here. I have the first equation that doesn't change, 7x plus 9y equals 200. But the second equation is going to become -7x minus 7y equals 24 times 7. Where's my calculator? 168 maybe? 24 times 7. Yeah, 168, but -168 because it was -7. Okay, so now I can, like I said, add these equations together. Since the x's have the same number but they're opposites, that's like 7x plus -7x, and that gives me 0. So the y's are going to give me 2y, 9y plus -7y. So that's 2y. And then if I take 200 minus 168, that gives me 32. And then if I divide by 2 here, that means y equals 16. And then you just plug that into one of your original equations. I'm going to plug this into this blue equation right here. So x plus 16 equals 24. Subtract the 16, we're trying to figure out what x equals. And 24 minus 16 is 8. So now we just need to write our answer in a sentence. So x is the number of clerk hours, the number of hours she worked as a clerk, and y is the number of hours she worked as a receptionist. So we're just going to write our sentence. And there's my sentence. Tammy worked 8 hours as a clerk and 16 hours as a receptionist. And you can always, double check your answers. Does that equal 24 hours? Yes, it does. 8 and 16 is 24. And does that equal $200? Well, as a clerk, she makes $7 an hour. So 8 hours times $7 an hour would be $56. And then as a receptionist, she makes $9 an hour. If she works at that job for 16 hours, that's 9 times 16. That's $144. Add that to the 56 from the other job, and yes, that equals the $200 that she made. So basically, I just took those numbers and put them into both of the equations, again, just to double check and make sure that it made sense. If I would have gotten, any other numbers, they either wouldn't have added up to 24, or they wouldn't have given me the $200 that she made. So these are the only two numbers that would work, the only solution for this problem. Okay, in the second problem, we have Old MacDonald again, and you might remember a problem like this from when we were graphing. We had done a problem with Old MacDonald having chickens and pigs. Well, I think you're going to be grateful that we don't have to graph on this one because the numbers are going to be really big. But the idea here is that Old MacDonald has a total of 52 chickens and pigs on his farm. Altogether, there are 168 legs. How many of each animal does the farmer have? So we want to know how many chickens and how many pigs he has. So those are our variables. So x equals the number of chickens and y equals the number of pigs. Now, he has a total of 52 chickens and pigs. So there's one equation. The number of chickens plus the number of pigs equals 52 animals. So equals 52. And altogether there are 168 legs. Well, how many legs do chickens have? 2. So 2x. And how many legs do pigs have? That would be plus 4y equals 168. So there is our system of equations. Now we're going to solve it. And again, you don't have one of the variables already by itself. None of our equations actually said that x equaled anything or that y equaled anything. So we can't use substitution. The coefficients are not the same yet. So we're going to have to multiply probably the top equation in order to get the coefficients to be the same. So which variable would you like to eliminate? Well, since there's nobody here but me to answer, I'm going to choose to eliminate the x. So I'm going to make it into a negative 2. So I'm going to multiply everything on the top by negative 2 so that the x's will have the same coefficient but also opposite, so I can add the equations together. So that will give me a negative 2x minus 2y. And 52 times negative 2 should be negative 104. Let me double check. 52 times... What was I thinking? Oh, wait. 52 times 2. It also helps if you put the right numbers into your calculator. Yes, that's negative 104. Shouldn't have even doubted myself. I had it right. But it's always okay to double check. Just make sure you put the right numbers into your calculator. Okay, 2x plus 4y is 168. That second equation is not going to change at this point. But now we are ready to add the equations together. Since the x's now have the same number, opposite signs, we're going to add so that they eliminate. Now the y's, this is a negative 2y plus 4y. That's a positive 2y. And negative 104 plus 168 is 64. Divide that by 2, and y is equal to 32. So there's 32 pigs on the farm. Now let's find out how many chickens. I'm going to take that 32 and I'm going to plug it into the top equation. I think it'll be easiest. Just plug that in for y. So you have x plus y, which is 32, equals 52. Well, subtract the 32. And x equals 20. So there we go. Now we are ready to write our sentence. So I just wrote simply that Old MacDonald has 20 chickens because x was equal to 20, and x was the number of chickens, and 32 pigs, and that was our y, and they're on his farm. So Old MacDonald has 20 chickens and 32 pigs on his farm. Aren't you glad we didn't have to graph that? We would probably still be putting them into slope-intercept form and making our graph, because you have to label your graph and deciding what to go by. So I'm so glad we have other methods of solving systems. Okay, let's do 2 more examples. All right, with problem number 3, we've had problems kind of similar to this. In fact, the first problem about Tammy working is kind of similar because it also deals with money. It just deals with like some amounts that are less than $1, so we'll have some decimals. But that's okay. It says Brian sold fruit at the farmer's market. Apples cost 40 cents and pears cost 50 cents each. In one afternoon, Brian sold 52 pieces of fruit and made $24. How many of each fruit did he sell? So there's our variables right there. How many of each fruit? So let's have x represent, what came first? The apples. So x equals the number of apples that Brian sold. And y equals the number of pears. We don't know how many of each. Number of pears. All right, now we need to write our 2 equations. So we have some money numbers that the apples were 40 cents and the pears were 50 cents and he made $24. So just be careful as you use your decimals here. You don't have to use your dollar signs, but with the x is the apples and those were 40 cents. So 40 cents times each apple, so 0.40x, plus 50 cents times each pear, which is y, equals $24. The other information is that he sold 52 pieces of fruit. So that's just your x plus y equals 52. And again, we're going to have to multiply so that then we can eliminate one of the variables. So we've been using that method quite a bit here. And actually, that method is probably used the most with word problems, simply because it's not often that you have the same coefficients in the word problems. So the multiplying method is used a lot. So which variable would you like to eliminate? Nobody answered. So I'll choose y this time. That's probably because nobody's here but me. So if I eliminate the y, then I want this y on the bottom to be a negative so that I can add, and it would need to be negative 50 cents. So I'm going to multiply everything by negative 0.50. That'll get these 2 numbers, the coefficients of y, to be the same. So for right now, that top equation is not going to change. I'm just going to rewrite it. 40 cents times x plus 50 cents times y equals 24. But the bottom equation is going to become a negative 50 cents times x, because I have to multiply this. I'm distributing that negative 50 cents, and then times that y, so that will also be a minus 50 cents times y, and then I distribute it also to the 52. Really, 50 cents is half, so if I could use my calculator, but it's just going to be basically half of 52, so that would be negative 26. Double check on my calculator just to make sure. Negative 50 cents times 52 equals negative 26. Good. Okay, so now I am ready to add, let's do this, add these equations together because my y's have the same number but they are opposite signs. So that'll get rid of those. Now back to my x's, that's 40 cents and then plus negative 50 cents. So it's really like 40 cents minus 50 cents, which is negative 10 cents, x. And then 24 minus 26, or 24 plus negative 26 would be negative 2. So we got negatives, but when we divide, they'll cancel out. Remember, with story problems, you shouldn't really get negatives in your answers very much. Divide here, which will help those negatives cancel out. Okay, so x is going to equal, let's see, what's negative 2 divided by negative 10 cents? Is 20. X equals 20. That makes sense. 20 apples, that would probably make sense. So now I'm going to put that back into the second equation. I think it'll be easiest. 20 plus y equals 52. Subtract the 20. And y equals 32. Yep. 20 apples and 32 pears. So now we just have to write our sentence. And there we go. Brian sold 20 apples and 32 pears. That definitely adds up to 52 pieces of fruit. And if I put those numbers in with those money amounts, it would come out to $24. Okay, one more problem. Bob and Joe, they're so clever. They give you a math problem to figure out their ages. The sum of their ages is 76, and then Bob is 16 years older than twice the age of Joe. And we want to find both of their ages. So right there, what it asks me to find, that's my variables. Find both of their ages. So x equals, we'll say Bob's age, because he was first in the problem. Bob's age. And y equals Joe's age. Okay, now we have to write our system of equations. This sentence is kind of nice. The sum of their ages is 76, so we know that if we add their ages together, we're going to get 76. The second, that other sentence is a little bit more complicated. Bob is, okay, so Bob is x. So x is Bob. So x is 16 years older than twice the age of Joe. So twice the age of Joe would be 2y, but 16 years older than that, so you have to add 16. So x equals 2y plus 16. Hey, we're not going to use elimination with multiplication, but here's our system, and this time we have one of our equations that has a variable by itself. So we're going to take what it equals, and we're going to plug that in. 2y plus 16, we're going to put that in for x. We're using substitution here. Kind of nice. So if we put what x equals 2y plus 16, we put that in for x in that first equation. That's going to give me 2y plus 16 plus the other y that's in that top problem, and then equals 76. Parentheses don't really matter because there's nothing to distribute and it's all adding. So we can just combine our y's here. 2y plus y is 3y plus 16 equals 76. And then continue to solve for y, so subtract 16. 3y equals 60. Divide by 3. And y equals 20. That was somebody. Who was that? Joe. So Joe's 20 years old. Now, to figure out what x is equal to, you have some choices. You can put that back into either one of the original equations. I'm going to go back up to the top and put y equals 20 right in there. So x plus 20 equals 76. Subtract 20. And x equals 56. So now we are ready to write our sentence or two. There you have it. Bob is 56 years old and Joe is 20 years old. All right, make sure that you do include all of those parts. You don't want to get that backwards. X was 56 and X is Bob. So you don't want to accidentally write your sentence the wrong way. I would have to take off for that. So just make sure you keep it straight. Okay, those are the notes for systems of equations word problems, and I think you have one more assignment to do before you start the official reviewing for the test that we're going to have on the 7th.